200 million years ago, scorching lava, suffocating heat, and toxic gases violently push our planet to the brink. There will be no mercy for anyone. Will our planet survive? Or will it transform into a barren wasteland, devoid of life? The fate of Earth's future lies with a handful of primitive creatures. They must adapt or die. Witness how the Earth was strangled on Animal Armageddon. This is Mars today. Waterless, airless, lifeless. A harsh, unforgiving desert where nothing lives, vastly different than Earth. The chilling reality is, this could have been Earth if a mass extinction 200 million years ago had succeeded. It happened just before the reign of dinosaurs, in a time called the Triassic. The world of the Triassic is dominated by humid jungle, with lush forests and vast wooded plains stretching from pole to pole.
The tropics of the Triassic would be like the tropics of today, but whereas in our world, as you go north or south from the equator, it gets cooler. Well, in the Triassic, it probably stayed warm because carbon dioxide levels, greenhouse gases were much higher. But I think the greatest difference would be the plants and the animals.
A host of bizarre creatures roam this planet. Flying reptiles, giant armor-plated herbivores, and cunning predators lurking in the shadows. But most important to humans, our own tiny ancestors, the first true mammals. All of these animals inhabit a vast supercontinent called Pangaea, the place land dwellers have called home for tens of millions of years.
The Triassic would have to have been one of the coolest crossroads of time to ever visit, I think. It really is this strange, peculiar intersection between what came before and what is to become after.
Planet Earth is still in recovery after the mother of all mass extinctions left it for dead. Million years earlier, the Permian period ended tragically when the Earth split apart in Siberia, oozing toxic lava for 1 million years. Known as the Great Dying, this cataclysmic event turned a lush and thriving wonderland into a barren, hostile domain. More than 90% of all species were lost forever. But a few animals made it through, and from this meager handful of survivors, life has slowly but surely clawed its way back from the brink. After 50 million years, ecosystems have returned to something approaching normal. But beneath their feet, the forces that brought Pangaea together millions of years in the past are now splitting it apart. The Earth's crust floats on a layer of molten rock called the mantle. The flow of rock in the mantle moves the continents over time. As these forces tear Pangaea apart, an extraordinary amount of lava will be expelled from the bowels of the Earth. The gears of mass extinction are in motion. Disaster is about to strike. In what is now the Appalachian Mountains of eastern North America, a deep rumble shakes the landscape. A startled flock of Eudomorphodon takes flight. They sense that something is wrong. But there is nowhere to run from the enemy gathering below. These bird-like creatures are among the first flying reptiles, or pterosaurs.
Pterosaurs were the first vertebrates to actually evolve powered flight, going not just from high up in the trees to down on the ground, but actually the reverse, being able to go from the ground up.
An elongated fourth finger forms the leading edge of their thin wings. To us, it might resemble a bat, but it flies as gracefully as a bird.
Was somewhere about the size of a seagull. And it could probably glide and flap its wings and would benefit from having those rather long wings that a seagull has, meaning that it can take advantage of air currents to maintain it aloft. It doesn't have to flap furiously all the time like a hummingbird.
And like a seagull, the Eudomorphodon use their gliding ability to patrol the waterways for food. They dine almost exclusively on fish. As the Eudomorphodons soar, another rumble. The Triassic world's grim fate is knocking at the door. Basking in the sun below, a group of Rudiodons take little notice that the end of the world is coming. 12 feet long, armored from head to tail, and equipped with large cone-shaped fangs, these Rudiodons are the top predators in the lakes and ponds of Pangaea. Rudiodon resembles a crocodile. Though they are not related to each other, scientists believe it occupied a similar niche in the ecosystem, an ambush predator that never strayed far from the water.
I think most of the time Rudiodon was eating fish, just based on the shape of the skull. But given the opportunity, something's not paying attention when it comes down to drink some water at the riverside, Rudiodon would probably be able to swipe at them and take them into the water and drown them probably.
But the dominant animals of the Triassic are heavily armored herbivores like Desmatosuchus. With no predators big enough to take them down, they roam wherever they please. They can grow as big as a 2-ton truck, and they're fortified against any potential attackers.
Desmatosuchus has got this full-blown armor all over its back with these giant shields and these giant spikes that stick off over its shoulders. No doubt that this could have been a great offensive piece of weaponry at the time when some animal is attacking it.
But Desmatosuchus's days of peacefully grazing are numbered. For weeks, all the animals of this place have ignored the mysterious rumblings. And now they will pay the price. Towering plumes of searing vapor stream into the sky. These geysers are like Old Faithful, but 100 times more powerful. Superheated steam and debris rocket over a mile into the air. And this is just the beginning. rolling clouds of steam subsume the Eudomorphodon. The Desmatasuchus lead the way to higher ground. While Rutiodon seeks shelter in the deep. But there will be no escape. The steam eruptions are just a warning shot. Lava eruptions are not far behind. Pangaea is coming apart at the seams. Weeks pass, and the steam eruptions in North America continue. One mother does her best to shield her young from the approach of Armageddon. This is Megazostrodon, our closest ancestor of this time. Its long jaws and rows of tiny sharp teeth suggest a reptilian origin, but it is covered in hair, not scales. Megazostrodon is the first true mammal. The future of the entire class of animals rests with it.
Megazostrodon was quite a small creature. You've got to think of something like a weasel, I guess, quite long and thin. You might hardly have noticed it, like weasels today. It's quite secretive.
And it's a pretty important survivor for us because it's the animal that is related to modern mammals. Probably, like most small animals of that size, is a burrowing animal.
Megazostrodon is well protected in its burrow. But those on the surface are not so lucky. The ground rumbles. Then, with an ear-splitting boom, the camp eruptions begin in earnest. Lava bursts out of huge cracks in the earth. Fountains of magma explode into the air. It's far more destructive than a typical volcano that explodes from a single mountaintop. These cracks can be dozens of miles long. A tidal wave of flame courses from the fissures.
Almost like a wave of this stuff slowly moving over the landscape, and all these poor animals in its way are running for their lives.
Herds of lumbering herbivores run from the walls of flame, but there's no escape. Their spikes may protect them from predators, but they only slow them down now.
Anything in its path is going to be immediately wiped out.
For weeks, even months on end, the fissures spew lava onto the surface. The molten rock destroys anything it touches, laying waste to the landscape.
We have no human understanding or connection to an event such as camp. Nothing like that has happened since humans evolved.
Animals evacuate ground zero. For those that used to live in what is now the east coast of the United States, there is no home left. As the exodus continues, one type of animal seems better equipped to adjust to the changes. The earliest dinosaurs, like Styracosaurus. Styracosaurus, and others like him, are just a few feet tall. But they're unique in this world, the only animals to walk upright on two legs.
Being bipedal is a very rare thing to do. Mammals do it in terms of humans and in terms of kangaroos. But dinosaurs were the first ones to really take advantage of running on two legs.
Styracosaurus is a nimble hunter. in a world of lumbering quadrupeds.
What a shock for all these animals. Gee, I've been on land for 100 million years. I've never seen anybody walk around with his hind legs before. It would have looked maybe ridiculous, but maybe not, once that thing started running at you at high speed.
While far from the T-Rex of its day, its prowess grows as larger animals continue to struggle.
We had these early dinosaurs not yet big enough to take down one of these big reptilian types, but certainly big enough to take down their young.
But even this nimble predator cannot outrun this devastation. The eruptions continue. Deadly side effects begin to take hold on every corner of the globe. The Earth has been set on an ominous path. How long before the blue planet becomes the red planet? For decades, horrific volcanic eruptions have spewed vast amounts of lava onto Earth's surface. The massive eruptions have a toxic effect on Earth's atmosphere.
The volcanic eruptions don't just produce lava, that's the most immediate consequence. They also produce a great deal of gas, which is dissolved at high pressure within the magma. As that comes towards the surface, the pressure reduces and this explodes out of the lava into the atmosphere.
Millions of tons of toxic gas are pumped into the air. The amount of carbon dioxide in Earth's atmosphere increases exponentially.
Well, let's take an analogy here. Let's go back, and instead of these volcanoes going off, let's say that we build 10,000 coal-fired power plants. Line them all up, tons of coal coming in, plant after power plant after power plant after power plant, all with their chimneys streaming up gas into the atmosphere. That's exactly what's going on with these magmatic provinces.
Temperatures skyrocket. It's unbearably hot. Even animals that live in the water, like Ruteodon, are affected. They lie in the shallows, trying to stay cool, but they must venture up onto land to lay eggs. It's a fatal flaw that dooms their species.
Some reptiles today, heat actually determines the sex of the embryo. So I could imagine back in the Triassic, if some of these animals had this type of reproductive strategy, where sex determination was based on temperature, you could drive a species to extinction by producing just males and males and males and males, and all you're producing is males. And so that would be a devastating way to kill off a species.
It's also far more difficult to stay nourished. The heat saps their strength. Insatiable hunger drives them to turn on their children, as crocodiles are known to do today. Cannibalism might well seal the fate of this species. The slow death march of extinction goes on. The sudden warming of the globe ushers in another catastrophic side effect. Oxygen levels plunge to record lows.
There's roughly half the concentration of oxygen in the atmosphere that we have today. So it would have been much more difficult, given the same respiratory apparatus, for an organism to breathe in the late Triassic than it would be for the same organism today.
In what is now the southwestern U.S., a herd of Desmatasuchus forages for food. The air is thick with carbon dioxide, the sun unbearably hot. Trying to breathe here is like trying to breathe at the top of Mount Everest. The big, armored beasts have never feared a predator. But now their greatest enemy may lurk within their own bodies. Their primitive lung system, combined with a sprawling posture, makes it difficult to breathe and move at the same time. Desmatasuchus saunters with a side-to-side motion, much like a modern lizard. As it goes, that flexion expands one lung and compresses the other, a trait called carrier's constraint.
Animals like lizards and salamanders that move in this sprawling way, where the body has to swing from side to side a great deal, that actually limits the capacity of the lungs and the capacity to breathe.
Just a generation ago, these massive beasts could roam for hundreds of miles, endlessly grazing like African elephants do today. But now every step is laborious. Herds of Desmatasuchus begin to localize in smaller areas. The low oxygen is also wreaking havoc on their reproduction rate. Conditions thrust the developing embryos into a lethal catch-22.
Now, if we go back to the Triassic, and oxygen levels are equivalent to being at 14,000 feet, your reproductive system is going to be vastly challenged. An egg has to have oxygen coming in through it, enough so that the embryo can develop. At the same time, an egg also has to hold water in. And so this is